Event-driven microservices are gaining a lot of traction these days due to their ability to kind of decouple different systems, while at the same time keeping the interactions real-time and dynamic. In this episode of The Artifact, I talked to Jonathan Schabowsky, who is the field CTO at Solace. So Solace is a company that enables enterprises to build powerful real-time event-driven applications. They have products like event brokers, event portals, and a cloud platform for events. Jonathan has had a long and rich experience working on event-driven architectures even before he worked at Solace. So I was super excited and grateful when he agreed to talk to me. So this interview was actually recorded way back in early 2022, but due to various personal reasons, all of them entirely my fault, I hadn't been able to publish this or really any other Artifact episode so far. But it's finally here. And even if you're a little bit interested in event-driven services, you have to watch or listen to this. So in this episode, I asked Jonathan about event-driven architectures, the drawbacks, the benefits, the mental model versus request response, and so much more. I hope you enjoy this episode and learn from it as much as I did. So here we go. So I want to start out by talking about event-driven architectures in general, because that's something that my audience is pretty interested in, and I'm pretty interested in as well. Because we all, as software developers, we kind of know what events are. We have a sense for what events are. And a lot of systems that I have worked on have had events in some form. But when somebody says event-driven architectures, there is kind of an implied importance to events. It's not just that events exist in the architecture. It's driving the architecture. So right. Can you talk about what event-driven architecture means to you in general?
Yeah, so I'm glad that the interest in this topic is becoming more pervasive for sure. I think it's interesting as well to take kind of almost two steps back even to go, first of all, how long has event-driven architecture been around? And obviously that answer is quite a long time. The uptake, though, has been sort of traditionally used in high performance computing and banking and those kinds of industries, and is now becoming much more common. I think it's becoming much more common because in general, when you're creating applications or designing systems, our goal is to design systems that are resilient and as much as possible real time. I've always kind of thought of the problem as we're really trying to make computers in a way function like our own brains, and our own brains really are in of themselves, I think, kind of a perfect system, and perfect from the aspect that, you're responding in real time to sort of all of your senses and all of your stimulus, and those are really events. And so if you can kind of transfer that now into whatever your use case that you're trying to solve is, it's really trying to break the paradigm that I think we all learned, at least I learned in college, of everything is a function. You call a function, you get an answer. But, that again, that's not how our bodies work, right? If I were to go and put my hand on a hot stove, I'm not going to query my hand going, is it hot now? Is it hot now? Right? Because in a lot of cases, when no one would want to put their hand on a hot stove. So you're doing something else and you're triggered by, oh my God, that's hot. Right. And so really that's kind of the way we would like organizations and businesses to really function, is to be really responsive to the needs of customers and changes, which just is, as you said, it's a different paradigm, and it means the driven part of event-driven does become a key. It is driving how your applications function. It's driving how you respond to these changes in stimulus, and really is why I think it is obviously a pretty interesting space.
That's an interesting point you bring up about most of the world is event-driven around us. I think when we're trying to find examples for event-driven versus this kind of request response thing, real world examples for request response are kind of, you find them in pockets, like a phone call perhaps, or even a phone call might not be a good example. So it's hard to find places where things aren't event driven in the real world. But you also brought up a valid point that when I was starting to learn programming, it was about, okay, I write a program where you accept an input, and then you process it, and then you return a response. And we didn't do a lot of GUI programming when I was learning Java. Probably because of the GUI limitations of Java, or at least at the time. I went into web programming, and then it was again, you get a request, you process it, you handle a response. So 10 years, 15 years of doing that, that request response model is kind of burnt into my brain.
Right.
So do you feel that that's a common challenge you see for people trying to understand event-driven architecture or trying to venture into event-driven architecture? They kind of have to break these habits of always thinking request response.
Yeah, I see it. And it's a good distinction you bring up as well of sort of I2 coming out of the more back-end Java space versus people that, for instance, come out of UI programming where UX is all about sort of handling events, right, that the user's actually doing. So when you talk to event-driven people around that are UX background, they're like, yeah, that's like what we do all the time. Right now, they're doing it more from a browser perspective, not an entire system perspective. But then those of us that are sort of back-end, I tend to, again, sort of think it arrives in our heads sort of when you're first learning to program and everything's a function, right? But then even sort of the way industry has evolved from a system to system communication perspective, I mean, really to go old, I'm not this old, but go all the way back to sort of like remote method invocation with Corva, right? It's always sort of been, and then SOAP was really invoking a method remotely as well. And REST is kind of like invoking a method remote, right? All of this sort of has this overall backing of then also the database, which is I'm going to do CRUD operations on databases, which tend to, again, have sort of a response type of a paradigm. And I think all of this has sort of led us to just become pretty hardwired into, for whatever activity I'm doing, I'm going to make a request and a reply. And if it is event driven, well, I'll just pull that endpoint until I find the change that I'm looking for, and then I'll act on it, versus sort of looking at the world in a little bit of a different way and going, what if I just announce what I'm interested in, and then you tell me when something's happens, and then I'm just going to basically be triggered on that. And again, it's also interesting because when you talk to database people, especially, I guess you could say older database people that wrote database triggers, right? Database triggers were inherently event driven, but way down in the database layer. So it's funny, very high up the stack with UI sort of has the event driven paradigm, and very low down the database stack had event driven paradigm, and everything in the middle somehow sort of, I think a lot of it just because of tooling and the way we think has sort of missed that boat over the years.
While this is a different paradigm that we talked about, I also hear a bunch of people saying, here's a common reaction that I've noticed to any new technology or any new paradigm. There's one subset of people who go, well, that's awesome, I want to adopt it. Other subset of people who go, well, let's see how it does. And then there is a third subset is like, this is nothing new. We've always had this before. I see this with when microservices kind of started picking momentum, there were people who were like, yeah, well, this is service-oriented architecture. We've been doing this for years. Similarly, when event-driven architectures are being talked about, people go, well, this is the enterprise service bus for people who are listening, who are old enough to remember that. But it isn't, is it?
That's a really interesting topic to me. So I did sort of come out of a little bit, I guess, about me, which will be fun. So I came out of college and I actually did some Java programming for about 2 years. And then I was actually focused more in the middleware team building enterprise service bus solutions. And so enterprise service buses, I actually think in concept were much more about sort of SOA and service-based architecture and proxying those services and doing mediations and transformations, which is actually the opposite of what any microservices architecture from Martin Fowler would be saying with smart endpoints, dumb pipes. We were making smart pipes and dumb endpoints, which created a lot of havoc, and all that havoc's been pretty well documented. Really event driven, while it does have an event broker or an event bus, it doesn't transform the data. All it really is doing is decoupling the producers and the consumers of information, which has a lot of benefits, of course, but it's not sort of an ESB kind of based architecture. And yeah, for all of those people that are sort of saying, we've had this before, or it's great in the new thing, or sort of I'll wait and see, like all of those are appropriate answers. Because I think if you look at it just from a publish and subscribe perspective, you go, yeah, we've had that for a long time. But just as any technology evolves, I mean, we've had computers for a long time, but nobody would say a computer from 1995 is the same as it is today, right? There's been incremental evolution and changes that have really evolved to sort of make it easier to use, more understandable, more manageable, more governable. So it's kind of, I think that it's matured a lot, which is why there is that excitement. And then, yeah, for those that are sort of, I guess, kind of in the middle, there's plenty of sort of, I think, exciting use cases that you probably use every day that are taking advantage of event-driven architecture. So
we're also learning from our mistakes. One of the things that used to really frustrate me about the enterprise service bus was there used to be this one big bus and one team that was managing it. And you have to get anything done. You just go to that team, kind of beg them or threaten them, whatever, to get something done. We don't normally get into that kind of a model when you're doing event-driven architecture. You don't have one team which is owning how events need to shape up. And that's an improvement right there. So I love what you said about it making improvements. You can classify it as kind of the same thing, but it is a new and improved thing. And every time there is such an improvement, you got to look at it and like, okay, there were certain reasons why the previous iteration failed. Have we solved it? Not that this is going to be perfect. We are probably going to make improvements later as well. But with the knowledge that we have today, is this good enough? So that brings up to another question that I have, which is like, okay, you have a system which is well designed, or at least as well as it can, with this request response model. And there are some problems, of course. No system is perfect. What is it that would make you say, okay, somebody who's working on a system needs to look at, okay, is event-driven architecture the right way for it? Or is that something that I should be considering? So what are the consideration points there for somebody to go, oh, well, let me go look at event-driven architecture?
Yeah, I think the consideration points would both be the need for sort of real-time information, I would say, is one big consideration. So for instance, if you had sort of some tracing or monitoring capabilities that would allow you to sort of see a particular client is just obviously polling on a resource looking for changes, you could basically provide them a higher quality of service with real-time information that also, I think, uniquely benefits you as an API provider in that it will cut the load on your API of basically just meaningless polling type information. But I think it also goes beyond that. I think like there are certain patterns like CQRS that have obviously sort of emerged as ways to sort of segregate your APIs from a performance perspective. And I think event-driven can play a role there as well of if, queries are always going, ad hoc queries, always kind of be best done with synchronous request reply because you can't predict what people are going to query for. But, certain types of commands or just state changes that things have changed, those can really be generally applicable to many different actors, whether internal or external to your organization. And so in some of my discussions I've had, for instance, with Gartner, Martin Fowler has said sort of event-driven APIs can sort of be a differentiator in the API marketplace and can even benefit from, potential, monetization use cases as kind of providing them as premium APIs. And so we've started to see that also as an emerging trend where, there's some discussions even sort of, it seems in the open banking kind of community of if all of these different users are just going to keep querying me, can I make money off of actually charging them if I just give them real-time data? And so all of that obviously means there's higher value in that real-time data versus just a single API. So I think that it's really kind of looking at it from your end user perspective, which you're always supposed to do when you're writing an API anyway, and just think about, is there a better way to provide a real-time information that these types of users would be interested in? In my background, one example is the air traffic management world and the FAA here in the US. Imagine if every airline had to go query the status of every one of its flights and its corresponding locations, right? That would be thousands and thousands of API calls a second, some of which will have gotten update, but a large proportion of those would also you could almost claim they're like misses, right? Oh, same spot it was, no new update. And so really, I think all the airlines ourselves, whether you're using Flight Radar 24 or FlightAware, we're able to sort of consume real-time information, and it makes a huge difference.
And maybe you mentioned database triggers as well. When you have a system which is using a lot of database triggers, that's another thing that might be like, okay, are we using the right events? Should the database tell that something changed, or should the system which wrote to the database instead make that communication? Do you think that's a fair assessment?
I think it's fair, and I think if you were to be using a lot of database triggers, I think you should ask a pretty fair question here. Why are we doing that, right? And then even I mean, you see now event-driven tools like Debezium, open source tool that all it does is monitor your database for database changes and then creates events, right? Well, then now you sort of have unlocked to your point of having to go and probably beg your database team to write a new trigger for you. You've kind of unlocked and democratized the data and that business moment so that now any sort of Java developer writing a Spring Boot microservice can actually be the one that does the trigger writing, right? So again, it follows that path again of can you just have smart endpoints and dumb pipes versus really the database being this incredibly smart thing. I don't think that makes a lot of sense anymore anyway.
I also used to think, like, when I was just getting into this architectural style and this paradigm, I started out thinking, well, okay, there are certain applications, certain types of problems which kind of gravitate towards event-driven architectures, like the air traffic controller example that you gave. But then this is a realization that I had. It's not necessarily the case. You can have a system which has request response, perhaps for the most part, and then there is a certain part of the application which requires it to be event-driven. And the classic example that kind of was this aha moment for me was like an e-commerce website, right? Mm-hmm. Somebody's browsing an e-commerce website, they look for a product, they kind of see the reviews. All that is a request response, right?
Right.
The browser is making a request, getting the response back. They add something to the cart, maybe even that is request response, but the minute they hit purchase, right? It's out of request response territory. The minute they hit that button, there are a bunch of different things that need to happen in a bunch of different spaces. And like all that, you have a choice. Okay, I'm going to say, okay, there are multiple systems, right? You have the billing system, you have the shipping system, the inventory system, all that. So one way is to do it is like have that do request response as well. And the other way is for that part of the application to be event-driven.
Right.
Is that the norm, though? Do you see applications where, okay, you have this part of the application which is user-facing, mostly a web mode of communication, which is purely request response, but then something that is not user-serving and something the user is not waiting for, something that will happen in the backend, that part is all event-driven. Do you see that as the norm?
I see it becoming the norm. So that whole sequence of events that you just mentioned within e-commerce, I think is a lot of sort of organizations, I hate to use the word transforming, but they're kind of transforming the way that they're doing that. And they're kind of coming from, I think, that orchestrated enterprise service busy sort of realm where you click checkout and now you're into a set of services, right? And they're much more going to, I think, the paradigm that you see this when you buy things on Amazon, where it's kind of like your order, here's your order number, your order is being processed. But it's not saying your order is done, because if any level of that overall problem, let's say that your credit card gets declined, right? Well, you don't get a synchronous response that it declined. You actually get an email that says, hey, your order has a problem. Here's the problem. Go in and fix your order, right? And what that really allows you to also deal with is the inherent nature of each one of these order fulfillment type use case components is sort of a downstream system. In a lot of cases, that's out of your kind of control. So what happens then when that's down, right? How long does it take for those systems to respond? Well, now your customer, if we're using Amazon, you're waiting there and you think the whole problem is Amazon, and it could be American Express or Visa or USPS or UPS or whoever of course now Amazon is everything, but whoever is fulfilling the shipment. And so really this kind of brings about the pattern of sort of like the deferred execution pattern and the idea that, the order checkout is the event that many other systems can basically act upon when they get to it. It also solves the problem of like the Black Friday event that everybody is trying to hammer your system all at the same time for one moment, trying to purchase this new item or the Black Friday case or the special sports ticket, right? You're going to overwhelm all of your downstream systems if you try to perform that now. Or you could use event-driven, just kind of consume and queue up all of these different events. And then as you get those resources, actually process them. And at the end of the day, the user is happy because it didn't have to sit on a website with a scrolling wheel wondering if it's actually going to go through. And all of your downstream services that you use are going to be much happier with you as well, that you're not going to kind of overwhelm them with a burst. So I think that there's definitely different patterns that can be used. But like you said, a lot of this is just trying to get it out of this orchestrated world to this deferred execution / more of a choreographed kind of a pattern.
Yeah, the distinction between orchestration and choreographed is an important distinction to make. And for a while, I had trouble understanding it because the thing about choreographed is if you look at real world analogies, even choreographed has this implication of there being one central choreographer, right? If you think about it, right? So choreograph is basically like, let's say a dance, right? Group of dancers are being choreographed. There is still a single choreographer, but the way we use the term in event-driven architecture is it's kind of self-choreographed, if you will, right?
Yeah. And I think it's also a difference in what happens at a given moment, right? So I'm going to use two analogies to sort of, and one of them will be the dance one, right? But let's start with orchestration, right? So at some point, the coach draws up the play, right? So, we're going to snap the ball. Quarterback's going to get it. He's going to throw to that wide receiver. That wide receiver needs to do these different maneuvers in order to catch the ball. Then on the field, that also means that inherently the play requires the front line to block, the quarterback to be blocked, to make the throw, the wide receiver to actually catch the ball that was thrown to him, right? That's all very orchestrated to me, right? Like you had a plan, and then in runtime of the play, it all has to come together, or like this is the quarterback's getting sacked, he fumbles the ball, we're in big trouble, right? I think in dance, whether you call it a centralized, let's just say it's the architects that are kind of deciding on what the choreography is, like deciding on what the dance move is. But then at runtime, each of the dancers, they are just listening to the music and they're performing it, the steps for what they know. So for instance, I'm a terrible dancer. If we were doing a choreographed routine, I'm sure you would be doing everything correctly. I would probably do nothing correctly, but you would still be successful. And maybe after I practiced more, I could be successful. And so I think if you look at that then from a service implementation perspective, that means if we both are listening to the same beat, your service can actually finish the work it's doing. But if I, for instance, go down or my database is down or some downstream service goes down, you aren't actually held captive by my failure. And you don't have to have all the retry logic and sort of change logic as to what happens if I fail, right? We're independent, we're independent services. And I think that to me is sort of what I think that really the nirvana of microservices should be, is that decoupling between the services, just like dancers are decoupled. Football players are not decoupled from each other.
Not decoupled, because if one person fails, the failure is essentially
failures to everyone, right?
Yeah.
Okay. Like if the left guard doesn't block and the quarterback gets tackled and the wide receiver can't catch the ball and he can't score the touchdown, right? And I think that the point though is there's always, no matter which style you're doing, there's still always sort of the architect and developer working together to decide what do they want to happen. And that's no different than the choreographer or the coach. The difference is what happens actually at runtime or in the play or in the song.
The thing is, there are some advantages to having this orchestrated approach, which is the first thing that comes to mind is, like, let's say there is one component which is doing like, hey, do this and then do this and then do this. Like, I want to know what the heck a system is doing. I'm going to go to that component. It's going to tell me exactly what the script is, right? So it's like, this is the logic, this is the flow, and this is what happens. But that's not like what the paradigm is about. So you have this guy here sending events. There's another guy who's listening to it, responding, doing something else, sending it to two other things. How do you make sense of a system if this is what's happening? Like each thing is autonomous, each thing is decoupled. How do you make sense of the flow?
Well, so you're touching on a point that is absolutely true, right? So if you think about it from a total choreography perspective, you do sort of have this this orchestrator. You do have sort of a single point of truth, if you will, of what's the state of really everything. Of course, there's a lot of performance and downsides to that, which we can obviously talk to, but just from a troubleshooting style thing, that can be pretty easy, unless we go back to the ESB world, which now you're relying on buying a beer for that team that actually knows how any of that works to help you troubleshoot that problem. But I think like in the choreography style, it used to be a bigger problem. And I think that fundamentally the biggest thing that sort of helps solve this, I would say, is we all write pretty good logs these days, and you have log aggregation systems. So, as your different processes are actually doing their processing, if you make use of logging correctly, then actually it can be pretty easy to troubleshoot that. There's two new sort of evolutions, I would say, that's also helping this become a little bit easier. So one is the ability to sort of better document your event-driven architecture so that then when something doesn't happen the way that you think it is, you sort of have a real life blueprint that informs you as to where you should go and look. Because, in this decoupled world, it's not like you can just do like stack traces of like, to which function am I having a problem with? You really got to sort of look at documentation. And so there's been some evolution there with things like event portals. The other one being something that's definitely much more underworked these days is tracing capabilities, like with open telemetry, where, if you just send a message with an open telemetry header in it, then basically these other systems can basically, you can basically see cause and effect as it ripples through your system. And then you can go, oh, I see this service is having a problem. That's why this order is never finishing. And then you can take action. So I guess the solution to sort of your overall problem actually can almost be summarized as more events and more sensing is really kind of the answer versus looking at it kind of from that one point down. It's really just collecting all of your events to sort of understand what is going on.
Some of those things that you mentioned are kind of already solved problems with microservices. And it's the nature of this problem is like a distributed systems problem anyway, right? So when you have microservices, even if they're doing request response, you want to know what happened in a certain user flow. You have to have telemetry. You have to have distributed logging and tracing. So it's just taking that concept and applying it to events. So rather than the only thing that changes is the nature of interaction between these systems, but then the need for having to tie all these different things together.
Right.
It's still the same. Don't you agree?
I agree. And I think like and I think also so all of these sort of, it's almost like it's like the law of distributed computing, right? Like all of the problems that microservices sort of have, I think are all a feature of their distributed nature, network problems, all of these different kind of concerns that just arise because you're distributed. I think like the most dangerous pattern though, I personally still see is that if you have a microservice that is acting as an orchestrator, inherently, I think you've just done sort of an anti-pattern of, did you not just create kind of a monolithic application, but all dependencies are actually distributed? Like, so basically you get the flexibility, I guess, of function reuse and composability of microservices, but you just basically like killed yourself because every function that you used to sort of have in your monolithic application that was like nice and local is now over the network, right? So I think that just separating things into microservices, but kind of sticking with that same paradigm can just actually exacerbate some of your problems. Whereas as you're really redesigning into microservices or building a new microservices application, I still personally think the need to ensure decoupling is very, very big. And the line that you want to draw of your microservices boundary, which is a whole nother topic, becomes very important because you can make them teeny and have terrible performance, or you can kind of make them larger microservices, maybe invalidating some laws, but actually gaining some performance. So there's a huge set of gray areas in that for any use case that you're trying to solve in microservices.
Yeah, no, that's fair. I was talking to Chris Richardson in this podcast earlier, and he calls the big problem with microservices is the partitioning problem. You're basically partitioning, and that's what translates to a distributed system. So when you do that partitioning, all these things are inherent, and the event-driven nature of the system isn't really adding any problems here. It's just something that you would have to do for any distributed system.
Right.
This brings up an interesting thought. I don't know if it's even a valid question, but the first thing that came to mind when you were describing that was we often think about event-driven architecture as a distributed architecture, but can you have an event-driven architecture with the monolith? Does it even make sense? Or does it need to be distributed?
Yeah. I mean, I don't think that there's like any particular, I think the answer is yes, and I think the answer is no all at the same time. So I think like if you want to take advantage of microservices and their ability to independently scale, then the answer to your question is no. Like having event-driven monolithic application doesn't make sense. However, can you claim that a application that's monolithic uses event-driven to communicate between its components? Like absolutely. In fact, look at Spring in of itself. Spring kind of has like a little embedded messaging system that you can use that fulfills channels, right? Well, you could draw your big old application box around that whole Spring application. It is monolithic, but it is still using event-driven to trigger processing internally. But you have no scalability help there because you've got to scale the entire application.
In your previous answer, you mentioned something about event portal. What is an event portal? Can you explain what that is?
Yeah, so an event portal really is a capability. There's a few of them out there that really, for the event-driven world, it provides you sort of the catalog of like, what are all the different events? What are their different types and what schema represents their payload? And then also provides you sort of the dependency graph of who's really the producer of that given event, who's consuming it. So sort of your application actors, so that you sort of do have awareness in that choreographed example before of, hey, okay, I know that this order checkout is occurring. That event is going to these 4 systems that produce these other events. It gives you really what is going on. So whether it's, I guess, shameless plug moment, whether it's Solace's event portal or Confluent and sort of it has they recently have this capability called stream governance. They're very different products, but they're all still in that realm of kind of keeping track of what all do you have and who's producing it and who's consuming it. So it's allowing your runtime to function as these independent decoupled services, but kind of providing you a cockpit of visibility of sort of from a human perspective, how are they coupled, right? Because ultimately the coupling is no longer at the interface layer, it's at the data layer. But that doesn't mean that there's no coupling. If you change the schema in a non-backwards compatible way and somebody gets it, they're going to choke on it. So there's always coupling, but it's just that application doesn't know if one application type or 50 application types or no application types are actually going to consume that event. And I think that's a powerful concept.
So it's mainly used as a documentation source, right? So it's an alternative documentation. And it's not, I'm guessing it's not manually maintained. When you change the code, it kind of shows you, hey, here is a change in the event. And for other
there's
how it works?
I'd say there's different strategies and different niches. So the Solace event portal is more focused right now on the documentation side. And it does have a capability that you can discover sort of from different types of event brokers, Kafka and Solace, and we can do it for Rabbit as well. Sort of it can infer a lot of that dependency model, right? Like you can see what topics are there. It can see what are the consumers and what are their subscriptions. We all struggle from how do you determine from a runtime who published it? Because the brokers don't do a great job of sort of documenting that. But then like Confluent Stream Governance does a pretty good job, I think, of more documenting, more, I think, from the troubleshooting perspective of, look, here's this producer, it's producing to this stream at this message rate, it's getting fanned out to sort of these other downstream consumers. So to me, they're taking a little bit more of an operator's view. This is my opinion of the problem. And we're taking a little bit more of the documentation design part of the problem and intending to sort of have that problem that solution be generic regardless of what type of broker you're using. Because fundamentally, most organizations, most large enterprises have not one broker type. I would even say not 2 different types of brokers, but probably 3 if you've been in business for like 20 years. You probably have IBM MQ, which is supporting mainframe use cases. You might have something like RabbitMQ supporting more modern queuing-based application use cases, as an example, or Solace. And then you might have Kafka being sort of the immutable events store of data for analytics, for different kind of historical perspective, and for obviously some real-time streaming use cases as well. So fundamentally, though, if you start to tie your brokers together through integration products, well, now you've got a really big problem of trying to understand what is and isn't happening.
So is it fair to say that this is kind of like the analogy, the first thing that came to mind was Swagger for REST APIs, right? So that's the model that I'm thinking of for event portals. Like for REST APIs, you somehow add an annotation or something like that, and then now you have this portal of APIs that people can use for referencing. It's basically documentation, right? Is that analogy fair? Like event portal is kind of like Swagger, but for events and publishers and consumers?
So I'm going to say no and explain why. So I think the corollary to Swagger is in the event-driven world is more like async API. So Swagger obviously being powered largely by open API specifications. So there's async API specifications. Then Swagger tooling obviously is a thing that allows you to like generate from that contract. It can generate sort of your stuff server or client code. Or Swagger can also, like you said, you can write annotations into your code that then sort of generates open API documents through Swagger tooling. Async API being pretty new, probably 3 years old, let's just say, it wants to follow the exact same paradigm as open API and Swagger. It just hasn't fully been developed yet. So for instance, there are code generators that can take an async API contract that a tool like an event portal in our Solace case can produce. You can do all your design, generate an async API spec, and run it through a code generator, for instance, that generates you a Spring Cloud Stream, Spring Cloud Function app. But what you yet can't do is add Java annotations into your Spring code that generates you an async API spec. We are starting to try to have some discussions actually with some I'll just say fairly key people at Spring to try to lobby for like, is there a way that Spring can help us with some annotations that can help with the async API part of this? So really, I think of async API and open API as corollaries. Async API tooling is to Swagger, and then event portal, I would say, is more like the equivalent of API management systems like Apogees or MuleSofts for the RESTful world that are now kind of bringing the same kind of concepts to the event-driven world.
Gotcha. So it's much more than just documentation. Get it?
Yeah, because I mean, ultimately, you start to get into the question of, so if you think about let's say you were to consume Uber's API, right? So you see their open API specification, you're like, yep, that's exactly what I want to be using for whatever you're trying to solve. So when you request access for that, there's a provisioning process to get you your token and get everything kind of behind the scenes working so that you can invoke that endpoint. We're trying to sort of also deliver that same kind of capability in the event-driven world where, like we have to do that same kind of provisioning. And that's also where the event portal is working to help that.
Cool. What is a typical development process like for somebody's working on an event-driven architecture? Would it start with this event portal to find, like, I have a use case. I want to know what API to call. I want to know what the payload is and all that. So would they start looking at the event portal, trying to figure that out and going from there? Is that a typical development process?
I mean, I think it should be, but I wouldn't say that's yet completely like the mainstream answer. I think today it's a lot more sort of brute forced, like lots of Confluence pages kind of documenting how it's going to work. You've got your schemas somewhere in some SharePoint or something like that. And then finally your developers are then going to take that and write the actual code that implements that. I think that there's two approaches that we see emerging that fundamentally work. And I think that, again, they ring very true from the synchronous API world as well. One is a design first methodology using a tool like Event Portal, where you are going to you could start out with just putting what are the application actors in there, right? And then going, okay, well, this type of system produces these types of events, and just define the event types. Then start to define, well, who should consume them? And then your next level of iteration would be, well, for each one of these events, what does the payload data definitions actually look like, right? So it's a very sort of holistic system design kind of approach. But the other approach that we also see is we're gonna kind of do more of a code first kind of an approach where, maybe you're writing a Spring Boot, Spring Cloud Stream microservice. You're just going to do all of that from hand. You're going to design your plain old Java objects. You're going to use the MIME type of JSON. So that Spring Cloud Stream and its magic makes it into those POJOs into JSON. And then after the fact, maybe it's your CI/CD pipeline that's really sort of going to update the event portal as to sort of what is there, right? So there's two different strategies, and I think what an organization decides to do is largely going to come out of their existing, like, what do you do with API kind of paradigm.
Interesting.
I do find it hard, though, in a distributed, I think what I just said on that last point, just to clarify one point, is that paradigm works okay as long as your microservices that you're working on are kind of all within the same bounded context and you don't have to worry about others. I think the minute that sort of you have events that are sort of spanning those bounded contexts or domains, then kind of the build it and it will all work out sort of starts to fall apart, at least from my perspective and my experience, just because you've lost track of who you're possibly harming by like changing these different events or event addresses or data types. So I think that's where design first, especially as your system gets more distributed and you have more people consuming these different events, definitely you're going to want to design up front what's the impact to others.
So this is how somebody who's developing an event-driven, perhaps microservice, knows what to do. But how do they run it? Like, how does a typical development process looks like? I have a fair idea of how request response process looks like. You spin up different test microservice instances. You have a service discovery thing. How does it work when somebody is building an event-driven microservice locally? What do they have to do in addition to their own code base?
Yeah, I mean, obviously you've got your own, like you said, you've got the code that you're actually going to write that then has a dependency in general on an external event broker, right? So depending on what your event broker choice is and how you want your tool chain to work, you can either run that event broker as a Docker container or some software on your laptop that just fulfills that requirement. That's what I would tend to do. Then you don't have to rely on your own network and connectivity and all sorts of stuff like that. And then as you go through the overall life cycle, you're going to end up deploying probably that code to some, for lack of a better term, platform as a service, some Kubernetes cluster running in some development environment that actually has a closer to instantiation of that actual broker. And then you'll go through integration testing and kind of all of that. I think that the tricky part in some cases is and this is something that we as a company are really working hard to solve, is that dependency on the outside resource has to also get configured, right? So for instance, if you're using Kafka, depending on, again, how your governance at your company works, like somebody is going to need to go in there and actually create like your topic and define what your replica set is and do all of this other work. And as a developer, I would like the ability to sort of define it centrally and just sort of make it so, right? And obviously CI/CD pipelines will do this for you, but who actually tells the CI/CD pipeline what to do, right? It's kind of eventually it comes back to the developer basically saying, well, these are my application requirements. Those application requirements somehow become configuration. And that sort of handoff is something that I think we from a event portal perspective are actually working towards, is can we actually, from what you define as an application designer, generate the configuration and even apply the configuration so that it's just all turnkey and easy.
That's a little tricky though, isn't it? Or maybe I'm looking at this problem wrong. If you have that one centralized place, you again lose the autonomy that people have of like, okay, I know my team wants to talk to the other team. I'm going to define this event and we are good to go. We don't have to involve any other team because we just have the producer and the consumer in agreement. Isn't that a problem when you have like the centralized place where this is happening because there are a lot more stakeholders involved?
Well, you don't have to have a lot more stakeholders involved, right? So this goes into sort of the tooling is there to ultimately make your lives easier. Governance is there to prevent people from hurting each other. It's kind of my view. And an organization's overuse of governance actually basically makes it painful for others, right? All we're trying to really solve fundamentally is if you're an application developer and you ultimately need to consume in order, let's say, events A, B, and C. Okay, well, if you're using the Solace platform, I know what that means. I need to create you a queue that has a topic subscription for X, Y, and Z using our specific wildcard selectors and all of that kind of stuff so that you get just the data that you want. But then on the other part, you're going to do some data processing on that stream. And let's say you're going to stick your outputs into Kafka, right? So you're going to put it into a Kafka topic and you need a certain number of partitions. Well, do you really want every developer to understand exactly what I just said? Or do you want them to basically easily be able to just design, well, this is what I want to take in, this is what I want to take out. These are the kind of quality of service things that I need. Is it guaranteed delivery on my endpoint in order? and let us deal with the fact of like, well, ultimately that results in configuration that gets applied to these two different types of brokers. So we're trying to actually make this easier so that you don't have to, in my opinion, you don't have to involve your middleware team, right? Because the minute you have to involve your middleware team to do it, now you're almost back to the age-old ESB paradigm that you referenced earlier, whereas really what your middleware team should be focused on is the running of Kafka, the making sure everything is healthy with Solace, making sure the operations is good. But the application level details, I think, should be handled by the application teams. But again, who wants to create configuration? I know I don't really like to create configuration. So can you create a tool that does that? That's kind of what we're trying to do. You know, it almost goes all the way back to like the database world. Like if you had to get your database administrator to create your table space and all of your tables, right? Like that was painful. And then things like JTA came around, which you could just define things, throw in some annotations, hit run, and it would just create everything, right? Like I think we're trying to get that towards the same kind of a direction with event driven is really fundamentally where I think things will go.
Yeah, it'll be good. So I think we didn't quite take on the promised benefits of JPA. I know that JPA does have these annotations, but a lot of places that I've seen, it's still like, yeah, JPA does this, but it's too much magic. We don't want that. So most of the times, developers writing those JPA annotations are basically trying to mirror what is in the database. Nobody runs things in production where the code actually modifies the schema because that's too scary, right?
Right.
So they again start out with the database being the source of truth, and then the JPA developers basically painstakingly putting the right annotation so that it exactly matches what's in the database. So yeah, I think there's a lot more promise there that we didn't end up taking. It'll be good to see that.
Well, and I think it's interesting too. Then if you go, okay, developers didn't end up doing that, which I do in general agree with. What I think we all did it at least in our development environments, and then to your point, by the time you get out, then yeah, the database administrators did it. But then what happened is there was the whole NoSQL revolution. Like, do we really need to predefine this, or can we just let the data define it? So that was another solution to that problem of like, I don't really want to predefine this stuff. So,
I want to ask you about the event mesh. That's again a topic that's become very popular lately, kind of in conjunction with event-driven microservices. Can you talk about what an event mesh is and why would somebody want to use one?
Yeah, sure. So let's go even back to one of your questions before about can you use event-driven architecture within an application, or does it have to be distributed, right? So I answered that question with, yeah, you could even make use of event-driven there, but you wouldn't really have a lot of scalability. But then let's say that you've got an application or a system that's running, let's say, on premises somewhere, right? And it's making use of event-driven and it's talking event-driven interfaces across. And now it needs to talk to another application, but that application isn't even in the same Kubernetes cluster, let's say on premise, it's up in the cloud. So now you've got basically a data distribution, data replication problem you have to deal with. And so really the idea of the event mesh is whether you're talking about application to application component within same microservices domain or across microservices domain or across physical sites or across clouds, all we're really talking about is just connectivity. We're talking about connectivity and federation. And so really the idea of the event mesh is that you can basically have a mesh of these different event broker capabilities that allow for the seamless distribution of event data regardless of where the application lives. So for instance, let's take a use case from the FAA because most people at least used to travel and hopefully are starting to travel. So when your plane leaves San Francisco, right? So you're on the plane, you got your headphones on, your plane backs out of the gate and you're taxiing. There's a system called Studs that actually is watching your plane move around the runways, right? The location, where is it supposed to be, all of that kind of stuff. And that system is probably in the air traffic control center for that region, right? So it's probably not at the San Francisco airport. So, but what happens after that, I think is really interesting, is a lot of that data does need to sort of go elsewhere, right? Is it sort of so far taxiing on time? Like, is the runway use going to impact arriving plane, right? Like, this is all actually a very tight system, especially at the major airports. So now that some of these location events need to not just flow within that system doing the ground surveillance, it needs to flow to the en-route systems. It needs to flow to the airlines. Like, lots of people need to get this. And so ultimately it becomes a very tricky data distribution federation problem. So if you had to then, as a system designer, basically make point-to-point replications, like you're back to like a whole ball of yarn problem, right? It's pretty nasty. So really what the event mesh allows you to do is simply go, you know what, the studs information is available on this topic and it's available from this broker. And then from an administrator perspective, you stitch these brokers to form a mesh. And so then any consumer, regardless of where they are, can make a subscription to their local broker, and the data it's kind of a self-learning system. The data then just starts to flow to that broker to be delivered to that client. And then the same is true for, let's say, one of data processing coming out of the San Francisco airport. Let's say that they have redundant networks, but let's just say something catastrophic happened and they lost network connectivity. Well, the mesh handles the fact that all of these events were fired. They're all being stored. So when internet connectivity is restored, then it's all streamed out, right? So even in the case of sort of like the rainy day scenarios, the mesh is accounting for sort of making sure that the right events get distributed to the right end consumers. But it really builds it out into you can have a much higher level of distribution with a lot lower cost to administer it.
So one of the implications of a mesh is that you're kind of moving away from, okay, this is a producer and this is a consumer, like you talked about point to point, right? And when you have a lot of these combinations, it does become a mess as opposed to a mesh, like you mentioned.
Right, yeah.
So an event mesh is basically a way for you to say, I'm going to take all of those individual point to point interactions, kind of remove them, decouple them, and have this kind of a publish subscribe. Anything that needs to send just publishes to kind of this global space. And anything that's listening to it is kind of picking from that global space. So kind of like making all these individual communications streamlined, organized, and in one central place so that something is publishing and something is consuming. Is that a fair way to look at it?
Yeah, you can think of it as one central place, but inherently incredibly distributed, right? So there is no sort of single point of failure. There is no one broker that has to consume everything to just redistribute it to others. It really is forming a mesh-based architecture. So that's a big part of it, but it inherently, I think, I like to talk a lot about this topic, so careful, but it allows you to basically also sort of, I would say, democratize data, because in a lot of cases, even with the API world, if I'm making an API available, I inherently have some power as to, do I really want to allow you to access my API or not? But in the event-driven world, is basically where we start to have applications just produce events. Then really now there is this sort of data being available everywhere to anyone that has the right access control. Now, who writes the access control lists becomes an interesting topic, but the whole idea is not to incur the cost of integration over and over again. If a piece of data is available, it's kind of almost free to have many people consume it as it is to have one person consume it. Because most of the time I find the hardest work is actually creating the producers of the events. The consumers of the events are pretty easy. So I think the event mesh sort of helps deliver that. I mean, anyone who's used, I'm not trying to like dig on other technologies, but anyone who's ever tried to sort of use like RabbitMQ or Kafka and sort of the way it does federation, WebLogic JMS too, they're kind of more like store and forward replication capabilities. Like think about database replication of like, I have my active site, I have my sort of this other site, I just need to synchronize data. That's not a hard problem if you only have two things that you're distributing data with. The FAA has 32 air traffic regional control centers. They all need to communicate. How many airlines are there, right? Lots. So for problems like that, that's really where the event mesh comes into play of really it's not just a replication problem, it's a mesh problem. And that's where, like I said, the event mesh really comes into play.
The thing you mentioned about democratizing data, this is the original promise of the internet, isn't it? Democratizing data, and the whole internet model of you make a website, somebody who wants it uses the website. I know it's not event driven, but then the idea of it being democratized, I kind of see a parallel there. But I also want to follow up on one thing that you mentioned about technology. The way I'm trying to understand this is not really a technology thing. It's more of like a concept, isn't it? Now, what's stopping me from having this big Kafka cluster where there are a bunch of topics, people are publishing, people are consuming, and then still having the benefits of the event mesh with democratizing of this data? How would you say that is different from a pure event mesh implementation?
Yeah, I mean, I think philosophically, it just, like you said, it's a concept. So if your business can have its needs satisfied by a single Kafka cluster using publish and subscribe, knock yourself out, right? Like, I think that's a great solution. You have inherently democratized data. I think the problem becomes where you have very distributed enterprises, very distributed computing capabilities, and even going into sort of IoT networks and edge networks where just physically it doesn't make sense to sort of have one Kafka cluster or one RabbitMQ cluster or one Apache ActiveMQ cluster, right? Like where you have a great example could be like connected cars, right? If you have millions of cars that are needing to sort of send out telemetry data, but also consume commands like to update the firmware or commands to unlock or lock the windows, right? So you've got millions of devices. You probably have deployed your command and control and telemetry things by region. You probably have a North America center, you have a European center, you have an Asian center. Each of these centers even probably has different regulatory requirements because of people's information. And what you now also have is you have back-end microservices processing the telemetry and creating the commands that need to go to the cars, right? So then how do you synchronize all of this together across your different regions, from the cars to your microservices and back? Like it could be a tricky problem to solve without the mesh. But with something like the mesh, all of your cars can talk something like MQTT, which is a pretty predominant IoT connectivity protocol that's inherently publish and subscribe event driven. And then on the back end, you could have your event-driven microservices in Spring connect to that same mesh and consume the events. And nobody is actually having to sort of do all of this protocol transformation. Like your microservice doesn't need to know the address of the car. It knows the VIN number of the car, and maybe you put the VIN number in your topic and the car is subscribing to its VIN number, right? So addressing becomes a lot easier as well. And I just don't know how you would just do that with like a single Kafka cluster as an example.
Yeah. That makes sense. Doesn't this bring up a whole lot of other problems, though? Like you have not really comparing Kafka cluster to an event mesh, but the concept of event mesh in general, because now you have data that doesn't have a single source of truth. Or would you consider the data in the event mesh as a source of truth? What is the source of truth in an event mesh? Let me ask that.
Yeah. So that's an age-old problem in of itself, is like single authoritative source and sources of truth. Mm-hmm. So events can absolutely be sources of truth. And a lot of organizations, some set of events are sources of truth. But there are other events that have attributes that aren't the source of truth, and other attributes even that are sources of truth, right? And then you have other events that actually aren't sources of truth. So that's my fancy way of saying every use case is different, and every requirement set is different, and every paradigm is kind of different, right? What's really important is to know which events and attributes are sources of truth for given information, which comes up again back to data governance as well as documentation, which is obviously important in all of this. I know in my FAA kind of background, like this was always an age-old problem of a system produces data that's a source of truth. It takes that data, does some additional processing, creates additional source of truth data, but also has the original data that came in with it for context, but it's not the source of truth of that other system is. So it just has to be well documented.
Right, because I was going to say, it's interesting that you brought up the FAA example, because there's this implicit belief in my mind that, well, when you're doing an event-driven system, it's well suited for something which needs eventual consistency, because you send out an event, as opposed to a database write, which is right there and you have one source of truth. It's okay for it to kind of figure things out as the events are being read. But with the FAA example, that's not the case. You can't do eventual consistency when you need to know where the location of a certain flight. So how does it work then? When, for example, publishing out an event and somebody needs to know what is the location of this flight at this moment. And here is an event which is making its journey through the event mesh. How does it work?
Yeah, it's a good question. I think the answer to your question is not black or white. There's different colors again here, right? So if you're thinking about the system that's controlling flights and keeping you as a passenger safe from colliding into other aircraft, that's really a real-time mission critical system that is also using real-time events, but isn't, I would say, using kind of commercial off-the-shelf technologies to do that, right? The pattern's still event-driven, but it has like 7 nines of availability or higher because, fundamentally lives are on the line for those kinds of use cases. In airline, though, in this kind of an example, they're an observer of the information. They're using real-time information to make operational decisions, which means the service level of that data can be less. It can sort of use a more eventual kind of consistent model because they're not trying to tell a plane to emergency kind of change altitudes, right? It's a different kind of paradigm. So anyone who's sort of worked on mission critical systems, whether it's in real-time controls of power plants or defense systems, inherently, there's a whole different design kind of concept that comes into those systems versus what I would say is the 80% use case that most of us are trying to solve is we have event-driven microservices, event-driven systems that we want to deal with inventory, deal with orders. That eventual consistency is totally fine with it. It even gets down into what is your latency tolerances, right? Or if you're talking, you need deterministic latency of sub millisecond into the microsecond level, or is eventual consistency to you, meaning as long as everything looks okay after 5 seconds, everything's fine. Well, there's just kind of different patterns that end up coming out of that.
So both these use cases can be served well by an event-driven architecture with an event mesh, right? It's possible.
Definitely each can be served by event-driven architecture. Each from a concept benefit from the event mesh. How you implement that event mesh may differ significantly between the two different use cases.
Gotcha. We previously talked and you mentioned the concept of events at rest and events in motion. I am curious to hear what is the difference between the two? What are they? And why would somebody need to pick one versus another? Can you talk a little bit about that?
Yeah, it's another good question. So data at rest versus data at motion, they ultimately both are obviously needed, but I think you kind of come up against the problem that at least today, I would claim no one solution sort of is best of breed. You're always sort of in a world of trade-offs. Mm-hmm. So as an example, to talk more concretely, like Solace and our brokers are very good at data in motion. They're very good at forming this distributed event mesh with the ability to sort of subscribe to sort of just the data that you want, right? So we kind of pride ourselves on being the data in motion, event in motion kind of a company. Kafka really, as an example, excels at having the ability to scale horizontally with storage, store a lot of different data types, be able to do queries of that data sort of that's sitting there. So really it starts to look more and more like a database that handles real-time events, that has a publish and subscribe interface, that has tons of value. So what we've sort of seen as an emerging pattern is a lot of organizations trust Solace in order to sort of distribute data where it needs to be. And then there's a Solace Kafka connector that can actually make the subscription, put that data into Kafka, and then those use cases that best benefit from the data at rest and analytics processing and machine learning can just use Kafka natively. But really, Kafka becomes a participant, a source, or a sink of that global kind of enterprise event mesh that we provide. And again, it's really just it's a difference in focus and it's a difference in concerns. Kafka topics, as an example, they're static, right? Like you define what your Kafka topic is up front, and in order to maintain order, you put your different event types into that topic. right? Solace basically says, no, you don't even define your topics up front. The topic is just a string that's in your message. And then you can use kind of what looks like we call them wildcards, but kind of almost looks like regular expressions in order to allow you to consume just the data that you want. So let's say, again, going back to our favorite now use case of the FAA, if you wanted to think about every consumption option of how you might consume aircraft position updates, the number is immense. Let's say I'm doing a study of just the arrivals into San Francisco airport, right? Let's say you are Delta Airlines, so you just want to consume Delta flights, and somebody else is doing a air traffic study of all arrivals and departures in the overall New York airspace, right? Well, with Kafka, in a way, you'd have to try to think about all of these cases up front. Whereas if I'm just the producer of aircraft position updates, I can put in there arrival airport, departure airport, the airline, the flight number, and then allow you to filter on that data however you want, right? Which then means if I then wanted to use Kafka to store a month's worth of arrivals into San Francisco, well, then I just use the Kafka connector and I say, I want to subscribe to KSFO / greater than. So everything related to San Francisco airport, and boom, now you're feeding data into Kafka. But if you were just to have started off with Kafka, how would the publisher know every permutation of how it should write copies of data to these topics, right? You just don't have the same kind of flexibility. So you've democratized the data into Kafka, but not necessarily in the consumption paradigm that the end consumer is wanting that data. I think that's kind of the difference.
Gotcha. What do you see as a common pattern that the Solace users are using to put data at rest? One, I've often seen something like Cassandra used more for keeping things at rest rather than something like Kafka. Like the use case is always you want messaging, you think about Kafka, and then, okay, do you want the message to rest or be in motion, right? Rather than somebody picking Kafka purely for storage when they already have an event mesh in Solace. What is the pattern you see for where people like to store data?
Yeah, it's a good question. And I mean, there are many different options, right? So there are some that use Kafka to store it, but that tends to be more for the AI, ML, or just analytics types of use cases. We more see, let's say that you're in banking, a lot of times you're actually going to put that data into in-memory caches for storage, right? Because you've got a latency concern. So you're going to use maybe something like, I mean, there's tons of them, but like coherence caches, right? Just as an example. Others might, on the other end of that spectrum, really just want more of a sort of a document style database. So maybe they want to put it into Elasticsearch. Others might want to take that data and put it in, have application code that puts it into a relational database, right? So like there are many sort of different options depending on what your use case ends up being. We don't really have strong opinions on what you do with the data once you pluck it off of us, though we do have integration. So for instance, we can, what we call a webhook, but you could basically create a subscription in Solace, and then you could actually configure us to basically deliver any data that comes in to Elasticsearch, right? Because Elasticsearch, obviously, you can just do posts to it, to a web URL, and it just inserts all the data, right? So really, I think just like how, well, I mean, I don't know. 15 years ago, everybody's answer to all problems was a relational database, and usually started off with the word Oracle, right? I think you just look at the data kind of paradigm now and you go, you've got different relational databases, you've got different NoSQL databases, you have Kafka. I think really it's just kind of opened up the world to whatever access pattern, whatever kind of query type you're kind of needing, you can ultimately get event data put into those resources as well. And people do it all the time.
Interesting. Do you see people putting, this into a relational database? I would pick something like Cassandra, which is right optimized for as like a consumer of events, just to save it into a state. But have you seen that more often, or do you see relational databases, or is it like a good mix of everything?
Honestly, it's just a good mix of everything from what we've seen, because I mean, there's all sorts of different use cases for why you want to store these events. And I think just each database does a good job on different areas of being able to sort of do that work. So, and then, yeah, I mean, ultimately, I just think it's in general a mix. Like I said, to me, it's sort of fundamentally divided up into how important do you feel that different relationships are, the documents and searchability ultimately ends up being, or the immutable event log, aka the order that the events actually came in being preserved. And obviously there's techniques to get around that too, like store the timestamp in your database and you can reconstruct the log. So I mean, again, it's a hard question to answer just because every organization has different use cases and they have preferred technologies. Like I would say a lot of organizations even will pick maybe not the perfect technology for a given problem, but they just have a lot of experience with that technology and it's still more efficient for them to use that technology than to optimize with a new one.
Inertia, right? That's a big factor in architecture that people don't recognize. It's like, why would you choose a technology? It's often, this is what you've been using. So that's very fair.
And it's actually also true, like I said, like whether it's, because we get asked a lot as well. So we already have all of this inertia. We already have all these applications. We already have all these databases. Like, how do we event enable things strategically and surgically without our answer being, we'll rewrite everything to the event driven, which is obviously something we would never say. I mean, that is where, again, things like Debezium come into play of like, can I look at your databases and as your writes come in, tell me what the writes are. And then, yeah, you'll have a microservice that needs to transform that Debezium weird looking event into like a canonical business looking piece of data, right? Another example is like our event brokers can run in what we call micro gateway mode. So we can actually proxy your RESTful services and generate events for sort of your different post, put, updates, deletes for given the different resources. And we can make events out of that. They are some funky looking events too, that again, you would want another microservice to basically do some logic to make them look nice for others to consume, right? But these are ways that really, and then the last one as well is, let's say you do have ActiveMQ or RabbitMQ or Kafka or whatever, and you want to expose events out of that. Well, that's where we have connectors. So there are sort of ways that without changing your code, that you can take advantage of these concepts and sort of putting them into an event mesh without sort of rewriting all your applications, which we would never propose that you do.
Cool. People are still trying to get their monolith to microservice transition going. They don't want to add another transition to the mix.
That's right.
Yeah. All right. So we are just about at close. Thank you so much for answering. This is very valuable and I learned a lot. I want to open it up for you to, like we talked about the shameless plug earlier. I'm going to ask you about what you do at Solace and why a listener would want to try out Solace, because it's this is like I have learned a little bit about it, but I'm curious as well. What would be a value proposition for somebody who's like considering event-driven approach for their architecture? Why would you say they would want to check out Solace and their offerings?
So Solace in of itself has been around for probably over 15 years. We are solely focused on event-driven architecture, helping customers succeed in building these event meshes, and really kind of being the guiding light to these enterprises as they go through that change. We've helped the FAA, we've helped 9 out of the 12 world's largest banks with event-driven architecture. So we're widely known in certain industries and totally unknown in others. We're getting increasing traction within the retail space, kind of even as you mentioned that use case. And so really what we really pride ourselves, I would say, on is having the world's most flexible as well as highest performance event broker. It's available in the cloud, it's available as software that you can run yourself, and it's available also in hardware appliances, which is where if you need 5 nines availability, sub-millisecond latency, we can give you those all with the same kind of look and feel as any of our other products. We have the event portal that helps you design, kind of take your event-driven designs and kind of go through their life cycle, which I don't think is matched in industry. And then the reason I care so much about Solace was previously, I was actually a Solace customer working some of these large federal government projects. So one was the NASA NOAA GOES-R weather satellite ground system. So that was where I became a Solace customer to start. So any weather imagery that you're looking at of the continental United States is actually that system. It actually does data processing. Solace is involved in that. In fact, that's where coherence caches are used as well, because it's really real-time streaming data processing is kind of that use case, along with control of the ground system is really what Solace is used for in that use case. But then the FAA also uses Solace, and I was a customer with that as well. And so really I'm not unique within Solace. There's a ton of us that actually have real world industry experience of trying to build event-driven systems. I've spent my entire career now, over 15 years, purely pretty much working in this event-driven space. So I think we're all pretty passionate about sort of allowing other organizations and enterprises to sort of have those same benefits that we've seen projects we've worked on and our customers achieve.
These are huge data sets you're talking about, like weather data, FAA data. That's a lot of data and a lot of events. So
Right.
yeah. So it looks like your folks can scale. So that's a good thing.
Yeah, I mean, and that is what we historically were known for, is our ability to scale and our performance. And really in the last 5 years, we've made a bigger focus on not just scale, but sort of event brokers anywhere you could possibly put them. And then finally now how do you have tooling that surrounds this to help the developer and the architect all the way through the life cycle of your event-driven architecture.
Let's start with the developer. A lot of the audience are senior developers or Spring Boot developers. How can they get started with trying out Solace? Is there a path for them to just try it out, build an application or a microservice using Solace? How would they go about it?
Yeah, so there's two things, and I guess we can have you do the traditional, we'll link below, but basically,
you got to do this. Yeah. All right.
You can basically get started with, if you want, super easy, basically just sign up for a Solace Cloud account, set up a Solace broker service. We take care of all of it for you. And there's literally a try me tab that you can send and receive messages just to play with it, right? And in there as well, there's like kind of code samples and snippets that you can use regardless of what your programming language is, but Java and Spring included. And then there's also a code lab, which we'll link to the description, I guess, below, that is on getting started with Spring Cloud Stream, Spring Cloud Function, which is, I think, if you've gone through the school of hard knocks for 15 years that I have of sort of starting out with IBM and writing MQSI sort of specific API stuff to JMS to Spring integration, and then now even into Spring Cloud Stream, Spring Cloud Function. Spring Cloud Stream and Spring Cloud Function is really a revelation in making event-driven easy and being able to get you started really quickly. And of course, it's all Spring Cloud, Spring Boot based. So if you're already sort of down that learning paradigm, then this is just a natural extension. And it's not Solace specific. There is a Solace binder that you use as part of your Maven and Gradle dependencies, but you could substitute Kafka or Rabbit or any of the other supported binders in there, and your code really doesn't change. Your config will, but your code doesn't. So.
Which is the promise of Spring, after all. So you get to be in that paradigm. So
it's a beautiful thing.
Yeah, yeah, cool. Well, thank you so much, Jonathan, for joining us and sharing your thoughts. This was very helpful, and I learned a lot. I look forward to speaking with you again.
Yeah, thanks for having me.